Hi, I'm Jeff Perry, the manager of the Webbench team at Texas Instruments. Today I'm going to talk to you about Webbench BOM management and how you can change components in your Webbench design. Once you've created your Webbench design, you can go to the summary page here and click on the Bill of Materials icon at the top. You'll see a listing of all the components in your power supply design. If you'd like to examine a particular component in more detail and look at alternate selections, just click on the Select Alternate Part button over on the right side of the screen. Now we're going to do a hands-on exercise with a live demo of Webbench. The design problem includes a design that was requested by management using the LM22670 with an input of 14 to 22 volts, an output of 3.3 volts, and a current of 2 amps. We're going to evaluate different inductor choices and try to choose an inductor with less than 5 millimeters of height. Okay, here's our Webbench design. As you can see on the left side, we've met the design requirements, the LM22670 with the previously mentioned voltage and current. Okay, we are on the summary page of Webbench now. If you click on the BOM icon at the top, you'll be taken to a listing of all the parts in the design. Here's the inductor that's used in the design, and if we select the Select Alternate Component button on the right side, we'll be taken to a listing of the alternate components for this design. Now let's talk a little bit about what's shown on this page. Up at the top, you have the selected inductor with the parameters. That includes the inductance, the DCR, and the current rating. It also includes the price and the availability of that inductor at our major distributors. Webbench has a library of over 20,000 passive components, and for most of those we get an active pricing and stocking inventory feed from our distributors. We also show the footprint, the height, and the power dissipation, and a top view image of the component. Below that are the limits that Webbench uses to calculate the design. In this case, the inductance, the DCR, and the current rating are the important limits for this component. Below that are the listing of the selected part and alternate parts that Webbench has chosen from the library. In fact, down here you can see there's 129 alternate parts that are displayed for this design. On the left side we see our Webbench visualization chart. So let me drag this little drag bar here to make some room. And you can see here that we have our x-axis, y-axis, and our bubble size as parameters. In this case, the x-axis is the power dissipation, the y-axis is the footprint, and the bubble size is the cost of the part. If you hover over a part, you can get more information about it, including the manufacturer and other details. Okay, let's say we want to check in here and look at instead of footprint, we want to be more concerned with the height. So we check the drop-down menu there, and we click on the height. Now we see a graph of height versus power dissipation and cost. Now we're interested in parts that are less than 5 millimeters. So we're going to click and drag with the mouse here and zoom in on that area of the plot to see what's going on. Basically, anything below this 5 millimeter line is going to be acceptable for our design. We're still concerned about cost here, so let's hover over some of these components and see what the costs are for the ones with the small bubble size. Okay, this guy here has a price of 47 cents. The green square is the one that was actually chosen for the design. That has a price of 45 cents, and so that's actually cheaper than the 47 cents. This has a price of 48 cents, and this guy's got a price of 48 cents. Some of the prices have I should say elements here have squares with X's in them. This means that we did not get a price for those parts. They were probably not in our distributor feeds. But as we can see here, Webbench has already chosen a part that's less than 5 millimeters in height, and it's also got the lowest price. So Webbench has actually done a pretty good job here of meeting our requirements right off the bat. Okay, let's say that even though Webbench has a large library of passive components, if you have a specific component that's not listed here out of our vendors, you can check the vendor drop down here and see that we have multiple vendors in the tool. But if you see a part or you have a part that's not in the tool, you can click on this Create Custom Part button. That will give you a dialog where you can enter in your own custom values for your particular inductor, and then use that in the subsequent calculations and simulations in Webbench. Okay, today we've talked about Webbench BOM management. We've shown a design where the BOM was calculated based on the user's priority for small footprint, low cost, or high efficiency. That was the original design that I showed there on the screen. Individual BOM components can be optimized using visual graphs. So you can make trade-offs between footprint, power dissipation, cost, and other key parameters like height, and you can zoom in and check out the details in the graph. Webbench has a library of over 20,000 passive components with inventory and pricing update, and you can also use custom components if you desire. Overall, Webbench design tools save you time. Thank you for your time today, and I encourage you to try Webbench tools yourself at www.ti.com/webbench.